Good morning all. I was just curious, what's inside a glue gun? Shall we find out? So I've got two of these low-cost glue guns, the type you get from DIY stores. Both were working fine. This one's now lost its spring, not because it broke, but because I broke it when I took it apart. Reminds me of when I was a kid. Don't take that apart, you'll break it. Now, the reason I'm chucking these out is because, well, they're not very good. I was manufacturing this product and I had to put a slug of glue in each end. And these things just didn't dispense a lot of glue for each pull of the trigger. This feeder mechanism just isn't very effective. So in the end, I bought a sort of commercial glue gun, which is this Tech 175-12. And this just has a much bigger trigger. And it just has a better feeder mechanism. So for every pull of the trigger, you got far more glue dispensed from the tip than with these cheap glue guns. So let's start taking one of these glue guns apart. Now, of course, they've got security screws. This one is Torx with the 6 lobes, but this one has the little nipple in the middle. So we need a Torx bit with a hole in it. Let's start undoing this. Here's a little tip. If you want to know when your glue gun is ready to use, get one of these things, a power monitor, power meter, which measures watts. Plug in your glue gun. This is the red handled one. And you'll see that initially it takes a lot of watts, 217, then 60 something, and that's now dropping. And you'll see that that will drop, gradually decreasing the speed at which it drops down to a sort of minimum value. And I came to the conclusion, I think it was with that commercial glue gun, that when it got to about 18 watts, it was ready to use, and the glue in the heated chamber was completely liquid. So yeah, just watch the watts and wait for it to get down to a nice low value. Right, let's take out the last screw and see what's inside this glue gun. I'll just remove the little stand there, and inside, this is not plugged into the mains, is that lot. So inside the glue gun there are essentially two parts. One is a mechanical pusher mechanism which grabs the glue stick with a little grabbing foot and pushes it into the heated chamber, so it turns the rotary motion of this trigger into a linear sliding motion of this gripper mechanism. Here's the spring. It seems to have come off the trigger here, which would normally pull the trigger back out to its outermost position. And I think it was attached to a little pillar there, which seems to have snapped off. And I'm not sure what's happened to that. I didn't see it. It's just vanished. Here there's a little seal, but it's odd. It's not a one-way seal. It doesn't act as a sort of one-way valve for the glue stick. It just simply centers the glue stick in this position here. Now the little tooth mechanism is quite interesting. You can see that when you first pull on this, the tooth, which is this little sharp, well, it's got a sort of semi-sharp edge, lifts up. The first thing it does is lifts up, embeds itself in the soft glue stick. It's in the down position before you start moving the trigger. Then it moves up, grips the glue stick and pushes it into this silicone rubber entry point to the heated chamber here. Let's just have a closer look at this mechanism for turning the rotary movement of this trigger into a sliding action for this gripper. And there's the little gripper movement. The little foot or tooth comes up, grips the glue stick and pushes it forwards. And then when this slides back, that releases the glue stick. So it's a kind of one-way valve. So it's a relatively simple 3-piece, or actually 4-piece, because there's a pin in there. So 4 pieces of plastic to implement that pusher mechanism. And then the other part is this heated metal chamber connected directly to the incoming mains. No switch, plug it in, starts to get hot. So on this heated chamber, or oven I suppose you could call it, we've got silicone rubber tip cover, just as protection, possibly partly electrical protection, because the mains does get very close to this metal. You still can touch the metal at the end there is an insulating layer, which is this Kapton tape, but it's not much really between 240-volt AC mains and this metal oven. So a silicon rubber tip there, a silicon rubber entry point here, held on with this spring. Ouch, that hurt. So let's remove this spring holding that on and remove this silicon rubber entry point. Oh, and I've broken off the glue stick, which is partly now inside here and partly inside this oven. I'm going to cut these two wires, which go to live and neutral on the incoming mains. I'll keep this piece of wire, that could come in handy. And we'll take a look at how this metal chamber, this oven, is heated. Well, it's heated by this, which is the heating element. It's a fairly tight fit in there, but I should be able to pull that out. Incidentally, the term silicone is actually a misnomer. Technically correct term for the various silicone rubbers is polysiloxanes or polydimethyl siloxanes. This from Wikipedia. So here's the insulating film. This is Kapton, and Kapton is a polyimide film developed by DuPont in the late 1960s that remains stable across a wide range of temperatures. So this is high temperature plastic. It conducts heat very well, but of course it is an insulator for electricity, and you would want that because the heating element is simply two pieces of metal with this in between them, and we'll look at what this is later, pushed into this metal. Oh, I think it's aluminium. Let's just check that. Magnet here. Yeah, these are aluminium with wires crimped. That's it. Crimped into these aluminium sort of semicircular blocks. This also appears to be aluminium. But I must admit, now that I've seen this, live mains is awfully close, just insulated by this film, to the metal nozzle of the glue gun. Not sure I'm too keen on that. So how does this heating element work? Let's come in a little bit closer. So we have mains directly across the surface of this. Now this is going to be some sort of ceramic material, but crucially this has what's called a positive temperature coefficient. So the resistance of this material will rise sharply when the temperature gets to a certain point, and we'll test that in a moment. Now I'm very interested to see this sort of surround. I wonder why there's this surround, or perhaps this is some sort of insulator, I don't know. But yes, main sits directly across there. Let's put the Kapton tape around it again and try and force it back into there and test the resistance across these two aluminium electrodes. So quite tricky to reassemble this and get the Kapton tape back in there. That'll probably do. All we want to see is what the resistance is across these two wires. Let's get a resistance meter. Strip these wires back. They appear to be single core, and just tighten them into these, and then I can put them straight into the meter. So at room temperature we've got almost exactly 1k ohms across that heating element. Let's start warming it up. I'm just simply going to put it in my hand and try to warm up this aluminium. And because this is positive temperature coefficient, we should see that as this element warms up, the resistance increases. Oh, it seems to be doing the exact opposite. And as it warms up, the resistance is decreasing. Interesting. So let's try and do this one-handed while I hold this in my hand so that we can watch the resistance continue to go down as I warm up this metal. So what's supposed to happen is that at a temperature where this needs to stabilize, and that's going to be quite hot because we need to melt the glue, it's going to be around 150 degrees, I guess, the resistance of the heating element will shoot up as the temperature goes up. So this is R, resistance, and this is T, temperature in degrees, well, whatever you want to use, but I'll put degrees Celsius. This will be resistance in ohms. Now this substance probably has an area where it has a negative temperature coefficient, and that will be as the temperature drops down to room temperature. So as I'm heating this up, the resistance is actually falling, but then when I reach a temperature at which, well, the glue is going to melt and we want to stabilize the heating, the resistance is going to shoot up quite rapidly as well. This will go up quite rapidly, and therefore the current flowing through this heater will reduce, and this thing will go into a thermal and electrical equilibrium. It's a feedback control loop of sorts, and the temperature will stabilize, and it simply won't go above that amount of temperature. And now as we watch the temperature of this block fall and the resistance actually rise, I just wanted to point out this. Both these glue guns are rated for 110 volt and 240 volt. This one says 50 hertz, but I don't suppose 60 hertz is going to be a problem. This one says it's 12 brackets 72 watts. Now my understanding of that is that it's a high power rating when it's cold, and then once it warms up it stabilizes at about 12 watts. Let's take a look at this one, the Loctite one. This says 110-240 volts, 50 hertz, 19 watts. So in an effort to show the positive temperature coefficient of this heating element, I'm going to shove the glue gun nozzle into my heat gun, switch that on the lowest setting, and try and heat this thing up sufficiently to get this down to its lowest resistance, and then to see it go back up as per this curve. I'm getting really hot now. That's going to have to sit there for a while, and maybe I'll speed this part of the video up. Okay, let's watch this go down and then hopefully back up again. Yes, that's pretty hot. That was a bit stupid really, because now this is going to be hot and I've got to put that back in there somehow. Now I measured the resistance of one of these heating elements just after unplugging it from the mains, and I think it was around, it's getting really warm here, it was around 150 ohms, so I'm expecting this to fall. Remember, this is still negative temperature coefficient, this is getting really hot, but the resistance is going down. We're still in this part of the curve, so it should go to about 150 ohms and then start rising up fairly rapidly, if I can get this thing hot enough. Right, now I can see that hot glue is leaking out of the oven here, down at the bottom here, leaking out onto my plywood. So the temperature of this oven is definitely hot enough to melt glue, but we're still not seeing that rise in resistance that we should be seeing if this is a PTC heating element. So is this the turning point at 176.6 ohms? Because it stopped falling. Is this the point at which it's going to go into positive temperature coefficient? And we should see the resistance shoot up, but I'm not seeing it yet. So we now are seeing a little hint of positive temperature coefficient at 177 ohms. That is climbing now, but it should have a fairly rapid rise as the temperature gets to the point where the glue is sufficiently melted in the chamber, and we want to reduce the current. We really want to reduce the current. We now want a high resistance. My heat gun is playing up. It is creeping up, but it's pretty slow at the moment. Now you got to remember, of course, that when it's the little slab of either ceramic or some sort of polymer material that's generating the heat, that material will be a lot hotter than the surrounding metal. Because I'm doing this the other way around, I'm heating the metal and waiting for the PTC element to raise its resistance. It is happening now, but it's really struggling to raise its resistance with the rising temperature. But I think we are seeing now the positive temperature coefficient, this part of the curve, and I'm getting very warm. So I'm struggling to get the temperature of this piece of metal high enough to see the positive temperature coefficient curve of the heated material. So I'm going to switch off the heat gun now, and so the temperature of this metal block will fall, and we should see a falling resistance. So that's definitely a positive temperature coefficient. Temperature falls, resistance falls. It should drop to about 176, I think it was, ohms. And then as the temperature of this block falls further, the resistance will rise back up, and that is this first part of the curve here. So let's see what the minimum resistance of that heating element is. It looks to be about 175 ohms or thereabouts. Yes, we're starting to see the resistance now of the heating element go back up this first part of the curve as the temperature falls. And I'll just leave that running for a minute and I'll speed it up. And now we're back to about the resistance, the maximum resistance I was able to get up when this was hot. So it's now gone through this low part of the curve, and the resistance is rising up as this cools down. So we're back to 500 ohms. This is still fairly hot. I can't hold that in my hand yet, but I'll just let that cool down, and then we'll take a look inside the oven there. And so now that this oven or heat chamber has cooled down, you can see, as the glue's all been removed from it, that there's really nothing inside there. Just a hole with a little smaller hole at the end. And so that is what is inside a glue gun. A very simple mechanical mechanism to push the glue into the hot chamber, and an extremely simple positive temperature coefficient heater, just this little block of ceramic or whatever it is, to heat up the chamber. It's really quite simple. Cheerio.